real quick here, but in lesson 1 we talked a little bit about some of the basic things that, well, basic I guess, but what are some of the basic things that we need to remember for math and formulas and some things like that that we're going to be using in this unit here. So just a reminder about significant figures or significant digits. Zeros in the front don't count. Zeros at the end do count. And any non-zero digit counts, like 1, 2, 3, 4, 5, 6, 7, 8, 9 counts. So if you remember 12.50, that would be 4 significant digits. 0.00, these don't count, these do, so that's 2. That's 2, and then the zeros at the end count, of course, so that'd be 4. Okay, so 4 significant digits, 2, 2, and then 4 for that. Okay, and we'll use that a little bit today because we're going to do some of this today here, of course. Okay, so again, yeah, okay, good, questions? Okay. Right. Again, so if we're dividing or multiplying, we have certain rules for this as well. We have 3 significant digits here. We have 4 here. So in this case here, we have 3 and 4. I should have 3 in my answer. We go based on the fewest significant digits. So when I do density, which is the mass over volume, again, we don't really do this a whole lot in Chem 20. I guess it's kind of part of it, but not overly. Let's see. We get 0.962 is going to be my final answer there. I need 3 significant digits because I have 3 in the question, right? 3 and 4, so I go with 3. When we add or subtract, it's a little different. When I add or subtract, I'm going to say, okay, well, we need to add up all these, 21.5, 2.78, 48, and 75.8, and we get 148.08 kilograms. And again, when we add or subtract, we go based on the fewest decimal places, which of course is different. So I look at the decimal places. Okay, this is 1 decimal place. This is 2. That's 0 decimal places. No, there is no decimal there. And there's 1 decimal place there, or 10th place. So in this case here, because there's no decimal places there, I cannot have any decimal places in my answer. So we're going to chop off the decimal places, basically. We're going to get rid of those and just call it 148 kilograms. Okay, that won't happen too often, but it does happen occasionally. All right, good. Okay, so again, no decimal places, so no decimal places is my answer. All right, we talked about scientific notation. You will have the questions that you do get today for homework. This will happen. We're going to have to, in some cases, use scientific notation to represent my answer, because if you only have 2 significant digits and your answer is like 145, well, we need to use scientific notation because 145 is 3. If we only need 2, we're going to have to use scientific notation. We're going to have to do some rounding. So just a reminder here, it's a number between 1 and 10, and then a power of 10. So 1, 2, 3, 4, 5 places. So it should look like that. And remember, in this particular example, it is set to 2 significant digits. So I just want to have 2 significant digits. Okay, 7.9 is the rounding for that one there, 7.9, and again 1, 2, 3, 4. Okay, 7.9 times 10 to the 4. 8.9 in this case, we are not going to round that. We're going to actually round that down. And remember, if the number is smaller than 1, we need to have a negative exponent. So 1, 2, 3, so it's a negative 3. And here, 5.9 times 10 to the negative, let's see, 1, 2, 3, 4, 5, 6. Okay, in that case there. All right, again, a number between 1 and 10, and a power of 10. If the number is smaller than 1, we need to have a negative exponent. Okay, next, we talked about the metric system. So today, we are going to have to deal with this a little bit as well once we get to the back side of our sheet here. If we're going down this chart, we're moving the decimal to the right. So if you're going down, for example, like maybe we're going to go from a kilogram to gram, we're going to move the decimal 3 places to the right. If we're going up the chart, we move it to the left, right? So you're going to get a little practice with that. Maybe a milli to back to the base unit here, which may be a milliliter to a liter, for example. We're not there yet, but eventually, when we talk about volume, we have milliliters, and we might have to get it to liters, okay, or milligram to gram. So in your homework today, if you see mg like this, okay, that's a milligram. This would be grams here, of course. This would be kg, kilogram. Don't forget there's one above here that's a mega. So if you saw 1 mg, okay, that's a megagram. I know it looks like magnesium, but it's a megagram because you're going to have a number in front of it. And that's 1,000 kilograms. Okay, don't forget that. So if you get a big M with a little g, it would look a little something like that there. Megagram to kilograms, 1,000 kilograms. And then if you wanted to get that into grams, it'd be another 3 steps down. That actually is in 1,000,000 grams. Okay, so left and right. And then we did this quick little example here, which was 275 grams into kilograms. Okay. Again, if you're in grams, you're going to move it, go 1, 2, 3 places to the left. So grams is here, and then we're going to go 3 places up, right? We get decagram, hectogram, kilogram. So 3 places up, so that's 0.275 kilograms. All right. This also happens with, of course, this. That is a what? What does that represent? It's going to happen today, actually, on your homework. What is mole? Millimole. Okay, so that's a millimole, and of course, doesn't matter what kind of mole you have, you probably want to do this. Yes. Kilomole. No. Moles are little animals that live in your garden and eat your vegetables, yes? That's what a mole is. There's actually something called a vole as well. It lives underneath your grass, apparently. It's different. A vole is different. But moles are little animals that live in your garden or underneath your garden. They make usually big tunnels, and they eat all the vegetables, especially carrots or roots from the bottom up, and then your garden doesn't grow. And then you figure out you got a mole problem, and then you should probably kill a mole. Get it? Okay. Not everyone's laughing, so I just thought I'd explain that. And
have you ever had a mole problem?
Actually, you know what? True story. Yep, I did. Okay.
Did you buy some gas, actually?
No. Did you kill it? Here we go. So just a reminder, molar mass. Molar mass, we need to add up all the atoms, of course. So we talked about this on Wednesday. On Wednesday, we talked about, if you had 6.02 times 10 to the 23 carbon atoms, and you gather them all up and you put them on a scale, the scale would read 12.01 grams. If you had the same amount for zinc, it'd be 65.41 grams per mole, okay, for 6.02 times 10 to the 23 of those, okay. Don't forget what in this unit here, we quite often talk about gases. So oxygen gas is O2. Fluorine, F2. Hydrogen gas is H2, N2, O2, F2, Cl2. Br2 is technically a liquid, but if we did boil it or whatever, we could talk about chlorine gas, bromine gas. We could talk about as well. Okay, so just kind of keep that in mind. As far as adding up molar masses, we have to make sure that we know how to do this. In this case here, we have some iron 3 oxide. We need 2 irons. So here's my 2 irons, plus 3 oxygens. So 3 times 16, okay, which is 159.70. You're going to have to write that in there if you weren't here. Here we have aluminum nitrate, which looks like this. 1 aluminum, yes. How many nitrogens do I need here? 3. How many oxygens do I need? 9. Okay, so add up all those and we should get 213.01. Okay, let's go ahead and do these 4 here. I don't know if we got that far last day or we did. Okay, we told you the answers too. I think it was what? 9. Help me out here. No, it's 1.09. Thank you. And then copper 2 hydroxide is 97.57. Nickel 3 carbonate is, help me out with that one. 197.41. Yeah, that's it, 297.41. And that's 331.61?
Yes.
Gram per mole. Okay, good. So we did those last Wednesday, I guess. or 2 days ago, I guess I should say. So hopefully you got those answers there, but we're going to have a worksheet. That's the front half of your worksheet today. You're just going to do some molar mass and formulas and things like that, for, naming kind of review. Today, okay, last thing before we're done here today, so you have probably quite a bit of time here, but we're going to talk a little bit about mass amount calculation. So this is review of Science 10, okay? In Science 10, we talk about this formula here, the mass amount formula. So we're going to copy this in here. Go ahead and write that down. Again, we have little m here, which stands for the mass. And the units that go with that has to be in grams. So again, if you have a question today, this is going to be the back side of your homework sheet. If you had a question like, we have it in kilograms, for example, well, we probably should change that to grams. Okay? Now, there's a way around that, of course, but we want units to match up so they cancel out. But there is a few options for that, but for our purposes, let's just make sure they match up. Molar mass is big M. Big M stands for molar mass, which is measured always in grams per mole, which we just kind of finished talking about with the chemical formulas and the calculating those molar masses. And N, now I kind of realized this, I guess, well, not today, but over the last few questions in Science 10 here, which we just finished, a lot of times they just ask for how many moles do you have of this substance or whatever. In Chem 20, you need to know that this is actually referred to as amount, okay? So if we ask you, what is the amount of this substance? What amount do you have? We're talking about, yes, we are talking about moles are the units that we're going to use there, okay? So that should be your moles there, which is amount. Please know that, okay? But again, look, if you're not sure, we're going to do this right now. So we're going to look at 3 examples. These 3 examples are exactly like your homework on the back page, okay? So we have one section for each of these. So the first section, I believe, is, I don't remember which one it is here, but we have a section that's based on just this example, a section based on that example, and a section based on that example down there. So we should have, 3 examples of basically everything that we need to do on the back side here, okay? But again, when we go through this question, it says what amount. Let's say you didn't know what that is. Well, that's fine. Calcium carbonate. What could you find out from calcium carbonate? First of all, you find out it's what? Huh? In here. Well, it's ionic, but calcium carbonate, the first thing that you find out with that is what? What could you find from that? The formula, right? You know what calcium carbonate looks like, right? And then if you know the formula, what do you know about it? You know the molar mass, yes? So we know the molar mass here, calcium carbonate. And look, this is the mass, that's little m, yes? So when it says what amount, look, there's only one variable to solve for here, right? It's n, obviously. So amount is n, so we need to remember that. And we're going to use our little formula here, and it's 27.5 grams. Now, calcium carbonate, again, super important that we write down the right formula, because obviously at this point, if we mess this up, then the answer's wrong, yes? And then the next part's wrong, and the next part's wrong. So calcium carbonate looks a little something like that. We're going to need calcium, 1 carbon, and 3 oxygens. I think it works out to be 100.09. No. Oh, yeah. No, I think it is. 100.09. Does that sound right, somebody? Yeah. 100.09 grams per mole. And I'll tell you really quickly here if that's right. I think it is. And if we do that, what is it? 27.5 divided by 100.09. We get, yeah, that's right. 27475 moles, of course, because remember, grams and grams cancels, right? And if you remember good old-fashioned dividing by fractions, or whatever the case, if you're dividing by a fraction, you multiply by the reciprocal, all that stuff. So if we have 1/1 moles, like that, we multiply by the reciprocal, the moles come to the top, so we end up with moles. How many significant digits do I need to have in this question? Well, how many are in the question? Let me put it that way. How many are in the question? 3. So I need to make sure I have 3 in my answer. Yes, I'm multiplying or dividing. So I need to make sure I have 3. So my best answer here, of course, is 0.275 moles. Let's make sure we circle it or something or underline it or something so I know that that's your final answer. Don't make me guess at your final answers because otherwise I always guess wrong. I have that ability for some reason. So please make sure you're clear in what your answer is going to be, what your final answer is. And I do mark on significant digits. So that is a half a mark in my books. Okay, we need to make sure we have significant digits. Let's look at the next one. What is the mass? What variable am I looking for? Huh? What variable am I looking for here? Yeah. Little m. What's 0.0027 moles? What letter is that, or variable?
N.
N. And then, of course, again here we have big M. We can find from zinc phosphate. Okay. Once we write out the formula, we can figure that out. I'd encourage you guys to make a list. Either do it like this, or make a list on the side. What are my variables? What do I have? Okay, et cetera, et cetera. Now, you have to solve, of course, it says, what is the mass? Well, right now, I've solved for the amount, yes? I mean, that's what this formula does. It converts mass into amounts and amounts into mass. So if I take this formula, how am I going to rearrange it to solve for little m, or the mass? You could do what? Multiply both sides by big M. So that'll get rid of that. And mass is equal to n times big M. Okay? You can, if you guys heard of this term before, you can cross multiply. Same thing. Okay, that'll come in handy probably later on down the road. So there's a couple of options, like, you know, they're basically the same thing. But I know eventually we're going to have 6 variables to solve. We have 6 variables, 3 on this side, 3 on this side, and probably my recommendation would be to cross multiply to start with, and then go from there. Okay, because we do need to isolate variables, and if you got 3 on this side, 3 on this side, you got some canceling to do. There's other options, absolutely. You can multiply by, flip that fraction over and multiply it, or whatever. You can multiply, divide. There's lots of options, but I like cross multiplying. Works well, but whatever. So now we have little m by itself, and we have what, 0.0027 moles. Make sure you put the units in here as well. And then of course we have the molar mass, which is something in grams per mole there. So first things first, I need to come up with the correct formula. Zinc phosphate looks a little something like this. 2 plus 3 minus 3, swap and drop. 2 comes over and down. So it should look like that. How many zincs do I need to have here when I'm adding them up? Quickly. How many zincs do I have? 3. How many phosphoruses do I need to have to add up? 2. How many oxygens do I need? 8. Okay. So add those all up. 3 zincs, 2 phosphorus, 8 oxygens. I believe we get this number here, 386.17 grams per mole. Okay. And of course, we're just going to go ahead and multiply these two together. I'll just double check that just to make sure, but I'm pretty sure that that's right. I'll tell you when we get the answer here, 386.17. Yeah, that's right. So we're going to end up with, I guess I'll just do it right here, 1.04 grams. Now, how many significant digits do I have in this question? How many? 2. Okay, zeros in the front don't count. So therefore, I can only have 2 in my answer. So right now I have 3. So we have to probably go to 1.0 in this case. So that's fine. That's 2 significant digits. Zeros at the end count, right? So that counts. 1.0. Good? Yeah.
Where'd you get to 1.0 from? Like how many, where do you see the significant?
Right here in the question. There's only 2. Yeah. Okay. Any other questions? Okay. All right, we're going to take a quick little break, not a break here, but I'm going to get you to do something for me here. Actually, I don't know, do we need to do that? I don't know. Let's do this anyway. An unknown chemical is examined and it has 3.86 moles of the compound. What is 3.86 moles? What variable is that? N. And it's found to have a mass of this. What variable is that? Little m. And of course it says here determine the molar mass, and that would be big M, yes? So we need to rearrange our formula for big M. We hopefully can do that. All right. And if not, if you're a person that is not, because I mean this happens every year, you're not great at solving for variables. Well, this is only 3. We're going to have, like I said, 6 in one formula, 6 in another formula as well. So if you want practice with solving for variables, you probably should come see me so we can do a little bit of that, because that's kind of otherwise if you mix them up, if you put this on top and that on the bottom or whatever, and it's supposed to be the other way around, obviously you're going to get the wrong answer. So we do have to be careful with that, of course. But again, just ask and we can do that. We can get some practice. How do I get big M by itself? Sure. Well, big M, big M. That's a great place to start. Yeah.
Wait, what's N again?
What's what?
Like, what does N stand for again?
Amount, moles. So that's a good place to start. Now I have this, and this is important, right? Now, did I solve for big M? Not yet. How do I get big M by itself now? What do I do? Divide by N. Okay. And that'll get rid of that. Okay. And again, there's different versions. There's different ways to do this, but not many different ways to do this. And we should need to come up with that. So if we're looking for big M, that is this formula here. Now, I caution you strongly, okay? And it's not just, it's not just this. Obviously, you might be thinking, well, I can just memorize these 3 formulas because, I give you this one on the back, by the way, in case you're wondering, which formulas do we get for this class or whatever. They're on the back of periodic. Whatever you see on the back of periodic table is what you can use. So I give you this one, but the other ones aren't there. Well, just you'll be like, well, I just have to memorize the other 2. Yeah, but that's not the point. You can. I won't know. However, when we get to 5, that means you got to memorize four formulas, 4 different formulas. When we get to 6, you got to memorize 5 different ones. Okay, and again, it's gonna become overwhelming and stuff. And we need to be able to solve for variables. Okay, for sure. And if you need help with that, let me know. But this is what we're looking at, which makes sense. We're going to have 275 grams and 3.86 moles. And of course, look, what happens if you're going to know if you did this right, because think about it. What's the molar mass measured in? What is molar mass? What are the units that go with molar mass? Grams per mole. Look, grams per mole, right? Grams per mole. So that looks right to me. If you flip this over, then you get moles per gram, which I don't know what that is. Okay, we don't do moles per gram. We do grams per mole. So that makes sense. You divide those 2. I think we get 71.2 grams per mole. Yes? And again, okay, normally we have 2 decimal places with molar mass, but we don't in this case because we don't even know what the substance is. We're just trying to solve for molar mass. So if we're trying to solve, we have to go based on what? 3 and 3. So I have 3 in my answer. Yes? Good? So just make sure. All right? So we want to make sure that we have, again, we want to use significant digits. I do take half marks off for those. If you don't have the right significant digits there and things like that, you might have to round up or down accordingly, of course, etc. Okay? Good? Questions, anyone? Okay. Again, when we get to the homework today, when we get to the homework on the back side, you're going to have things like kilomoles, okay, which of course, again, you want to get those into moles, okay? If we have something like megagrams, well, you're going to have to get that into grams, probably, okay? So we want to make sure we do those conversions. So that's going to take a little bit of time for you, just to make sure we're on the right track there. A milligram, okay, again, we want to get into grams. If we had, I think there's a question with a millimole. Again, you want to get those into moles, right? That formula only does 3 variables: grams, grams per mole, and moles. So those are the units we probably should be using. There is ways around it. We're not going to talk about it, because unless you understand it, that's fine. But well, we're going to leave it like that. We're going to change it to grams. We're going to change it to moles. We're going to use grams per mole. Okay? All right? Good? Okay, I'm gonna grab your worksheet here, which will be due for Monday.